to do when I'm standing here versus over here to accommodate the bright light? What? They have to constrict. My pupils are going to constrict. And the question is, how can that happen when my eyes are essentially just collecting light data? Well, the light data is coming in as not just light, but intensity of light. Okay. So the light data is coming in, it's coming back to the lateral geniculae. The light data itself is now being sent back here. However, you're sending signals in from both eyes. Okay, so we have signals coming back here to the pretectal nucleus. These signals coming back are saying, you know, we've got too much light coming in. Too much light. What's going to happen to my pupil? They're going to constrict, so they're going to get smaller. Or you say, you know, you're in the dark part of the room. I could use a little more light data. Let's open them up. Those signals are being interpreted entirely in the midbrain. So, you know, I wish they could show you all of the things going on here, but it's a little complicated. Now, the signals from this eye, or whatever eye that is, comes back in, goes to both pretectal nuclei. The signals from both pretectal nuclei go to both Edinger Westfalls. The signals from both Edinger Westfalls go back out to both eyes. 3 sets of redundant signals. This is a ridiculously redundant situation. This means, with this eye alone, this one's closed or covered up. With this eye alone, signals come in, signals go out to both eyes saying, you know, if I need to get more light with my right eye, then I should also be getting more light with my left eye. The signals are so redundant because if I have a problem here, is that going to affect my pupil response? What do you think? What? Okay, so you have a stroke, knocks this baby out. It's not there. What about your pupil response?
Still there.
Why?
Because you have the other one working.
This one's working, but also both eyes have this. You have 4 sets of signals coming to these. From these, you've got 2 sets, 4 signals going out, 2 sets of signals to each one. The amount of damage that you have to do to lose one of these reflexes is outrageous. If anything, you just about have to damage this. If I knock this out, then I'll lose the reflex. But anything shy of knocking this out, there are redundancies. Because the signal coming up here is coming from both of these. The signal coming here is coming from both of these. The signals coming here are coming from both of those. 3 sets of redundant signals. So when you think about you as a human and vision, what you have to remember is your vision has so many components in the brain, it's really outrageous. So, yeah. Yeah, we are going to spend more time on the optic pathways in the near future. This is just kind of the beginning. All right, so you should, though, please review this figure, the way the signals are coming in, going out, the involvement with the pupillary reflexes, which is parasympathetic or sympathetic, the involvement with vision, which is just, you know, cranial nerve 2. Anything else? else in that? Yeah.
You mentioned that the majority of the fibers running back to the chiasm that cross are contralateral, whereas
So-
only a few are ipsilateral? Or is it more equal?
It's not entirely equal. More signal crosses than goes straight back. And years ago, we would have said it was 75-25, but I think it's much closer to 60-40. Yeah. So, and what it's showing here is the signals coming back and crossing and some of the signals going straight back. But you have to remember, you've got so much bouncing around in here that the response is equal in either eye. Number 3, the oculomotor. Oculomotor innervates many of the little intrinsic eye muscles. Your eyes so you've got 4 muscles that moves your eyes laterally, medially, superiorly, inferiorly. They're named pretty much as rectus muscles. So we have the medial rectus, the lateral rectus, the superior rectus, and the inferior rectus. This allows your eye to move left and right, up and down. But now I'm going to ask you to do something else. I'm going to ask you, look straight forward, and then look up to the right side, or for you, left side. So look up at an angle. Now that's a complicated movement. And you think, oh, but if I just pull it laterally and superiorly, I'm going to get there. You're not. You're not going to do that. If you did that, you'd have to look left and then look up. Or look right and look up. Whatever it is. And that's not the way it works. It turns out you have 2 other muscles. And those muscles are the oblique muscles. Now in here it's showing the inferior oblique. And you also have a superior oblique. The 2 oblique muscles have the ability not to move your eye like this and like this, but like this. And it allows you to look at all of those angles in between what you would just see at 90 degrees. The oculomotor nerve doesn't do all of the muscles. The oculomotor nerve is involved with the inferior oblique and all the rectus muscles except the lateral rectus. So the superior, inferior rectus, and the medial rectus. It's also involved with the levator palpebrae. That's going to lift your eyelid. So it's involved with a lot of movement of the eye, but not all of it. Once again, we are going to be revisiting this and looking at the complexities. Number 4 is the trochlear nerve. The trochlear nerve innervates a really bizarre muscle because as far as I'm concerned, with muscles that you own, this one is unique or very close to being unique. Because this muscle, the superior oblique muscle, travels through this piece of connective tissue, the trochlea, and does a right angle. So the muscle does this. That's weird and bizarre. When the muscle contracts, it pulls the eye inward. Strange. But really now, when you think about it, at the upper surface of your nose here, the bridge of your nose, you don't have a lot of room up here for a muscle, very small space, to contract and cause your eye to rotate on that angle. So the majority of the muscle is back here. This is the equivalent of the tendon. The trochlea is this little piece of connective tissue that allows the muscle to sit there like this. So it holds it in place. So when the muscle pulls back, it pulls the eye inward and upward, which is really kind of cool. So, trochlear nerve innervates the superior oblique muscle. As we move on, we come to one of the truly crazy cranial nerves, number 5, the trigeminal nerve. So here we have the trigeminal nerve, or coming out from the brainstem, from the pons. We're going to pass through the trigeminal ganglion. There's several other names for this ganglia. We'll look at some. And then it divides into 3 main branches. Okay? So we are going to have the ophthalmic branch, or division. We're going to have the mandibular division down here, and we're going to have the maxillary division over here. Now, when we look at your face, you remember when we talked about the dermatomes? There were dermatomes that involved your face as well. And they were called V1, V2, and V3. This is for the branches of the trigeminal nerve. These are all sensory. But at the same time, the trigeminal nerve innervates the tongue. Okay, it's going to give you some taste sensation. And it innervates the pterygoids, the temporalis, and the mandible, as well as part of the digastric muscle. This is going to allow you to move your jaw and chew. So you've got this complex set of innervations involving sensation and chewing. Here's the figure in your textbook. So here's V1, V2, and V3, the 3 branches, the ophthalmic, the maxillary, and the mandibular, having to do with sensation. So, complicated. Trigeminal. Number 5. We go to number 6, okay, the abducens. The lateral rectus muscle. So close your left eye and abduct your right eye. So move to the side, right? And go laterally. But what happened to your left eye when you did that? It what? It's moving. And what did it do? Okay, what? Moves in the same direction. So did it move laterally or medially? Yeah. Crazy. Some of your cranial nerves operate together flawlessly. And oculomotor and abducens, great example. Because as you look laterally with one eye, the other eye is moving medially. Now, can you move your 2 eyes both laterally using the abducens? What? Yeah. Simultaneously. You can. Why? What would that do? I don't know. I can't even come close to doing it. Can you move them both medially?
Yeah.
You can. Another test they would do when you go in having your eyes examined, and they say, but